Assalamualaikum warahmatullahi wabarakatuh. My name is Nazmin Al-Fabian Jamaluddin. Metric numbers AA240054. So today I'm going to talk about introduction of hydraulic lift system. So first of all, we have a definition. The hydraulic system is a mechanical device that used to lift heavy loads by applying a force through a liquid. So the main purpose for the hydraulic lift is, of course, lifting capabilities, and the advantage is multiply a small force, multiply a small input force to become a large output force, and it used to more easier for human to lift the heavy load.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Masakin bin Fadlan. My metric number is AA240153. So today, I will be presenting about the hydraulic lift design. As you can see, hydraulic lift is a system that uses liquid, which is usually hydraulic oil. It used to lift heavy loads with a small applied force. It is commonly used in car workshops, elevators, hospitals, and industrial machines. Other than that, the hydraulic lift works based on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. This allows a small force on a small piston to generate a much larger force on a big piston. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Masakin bin Fadlan. My metric number is AA240153. So today, I will be presenting about the hydraulic lift design. As you can see, hydraulic lift is a system that uses liquid, which is usually hydraulic oil. It used to lift heavy loads with a small applied force. It is commonly used in car workshops, elevators, hospitals, and industrial machines. Other than that, the hydraulic lift works based on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. This allows a small force on a small piston to generate a much larger force on a big piston.
Okay, my name is Hassan Hadi bin Hassan Musid. My matrix number is AA241718. Okay, now I'm explaining about operation of hydraulic lift. First, the hydraulic lift fluid is stored in a reservoir. When the system is active, the pump pushes the fluid into the cylinder. Then pressure is created into the fluid and transmitted throughout the system. According to the Pascal law, this pressure is equally distributed. As the pressure reaches the larger piston, it produces a greater force due to the larger surface area. This causes the piston to move upward and lift the heavy load. To lower the lift, the control valve is open, the fluid flow back to the receiver and the piston moves downward smoothly. Now I'm explaining about how the system works. The hydraulic lift works based on fluid pressure input system. When force is applied to small piston, it creates pressure in the fluid. This pressure is transmitted equally to the larger piston. Since the larger piston has a bigger area, it generates much larger output force. This is how the system is able to lift heavy load with a small input force. In this system, energy is converted from mechanical energy into hydraulic system, and then back into mechanical motion.
So my name is Wan Mazim bin Wan Fauzi, and my matrix number is A242005. So now I want to explain about how fluid mechanics principle applied in the system. This system applies Pascal's principle in fluid mechanics. When force is applied to the small piston, pressure is created in the confined fluid. According to Pascal law, the pressure is transmitted equally throughout the fluid. Because the output piston has a larger area, it produces a much larger output force. This allows the hydraulic lift to raise a heavy vehicle with a small input force. The relationship can be shown by the equation F1 per A1 equals to F2 per A2. From this equation, we can see that increasing the piston area increases the output force. That is why hydraulic systems are widely used in car lifts, brakes, and heavy. Okay, here's a simple calculation showing how the hydraulic system multiplies force using Pascal law. The input area is 0.02 meter square, the output area is 0.80 meter square, and the input force applied is 250 Newton. Since the pressure is equal throughout the fluid, we use the formula F in per A in equals to F out per A out. By rearranging the equation, the output force becomes 10,000 newtons or 10 kilonewtons. This shows that a small input force can generate a much larger output force because of the larger piston area. Next, using Newton's second law, we calculate the mass the system can lift. F equals to mg. The hydraulic lift can support a mass of approximately 1019 kilograms, which is about 1 ton. Lastly, the mechanical advantage is obtained from the ratio of the output area to the input area, since 0.80 divided by 0.02 equals to 40. The system magnifies the force is 400 times, is 40 times, making it easier to lift heavy vehicles with a small effort.
So, in conclusion, hydraulic lift is a perfect example, an easy example of Pascal law that apply a small input force that become a large output force. This is allowing a small amount of human effort to easily lift heavy vehicles or heavy loading. And lastly, we use a fluid for that can turn massive and dangerous lifting into a smooth and safe for the task.